So I just remind you kids, if you got anything up to 8.1 that you need to turn in, I'll probably be updating grades later on this afternoon. I know all of you guys are really in great shape, but if you see anything that shows up as a 0 in there, just get it into me. If I've screwed up, let me know. Sound good to everybody? Okay, guys, last section was titled Geometric Vectors. Today we're going to talk a little bit more about algebraic vectors. But the thing is, when we were converting from polar coordinates to rectangular and from rectangular back to polar coordinates, we were kind of doing algebraic vectors already. And it says in studying geometric vectors, we saw that we needed to draw some pictures, and we had to be very accurate. We kind of went the route of we want to know what direction it's going, but we want to find the exact values by turning polar into rectangular. But when you measure stuff, you have to be correct for the magnitude and the amplitude. But today we want to see that adding vectors is much more accurate if we involve the algebra. Most everything we see today will involve, what kind of form is this right here?
X coordinate.
X comma y. So is that polar or rectangular?
Rectangular.
We're going to be dealing with a horizontal component and a vertical component. Horizontal is my x, vertical my y. So right here, maybe make a note, say, whoops, hang on one second. Make a note right here and say, maybe this here is my way of saying rectangular form right here. Okay? So you guys recognize that, right? So guys, why is b 4, 5 a vector? How would you describe this vector? If I said 4, 5 is a vector in rectangular form, what would that look like in a coordinate plane or a rectangular plane?
From the origin to 4, 5.
So anything in standard form is going to start from the origin and go from 4, from 0, 0, and move to the point right 4, and up how much again, Christian?
5.
Okay. And when I draw this line segment for that vector, where am I going to put my arrow at?
End.
Okay, which end?
End on the right.
Yep. Okay, so it's saying go in that direction. Okay, so 4, 5 is a vector because it's in standard position. It starts at the origin and goes to 4, 5, and it moves that direction. So the question becomes this: what happens if we talk about an ordered pair that represents the vector from 6, -3 to 2, 0? So for instance, where are you starting this time? You're starting at 6, -3, right?
Yeah.
And where are you headed to?
2,
2, 0. Oh boy. So if I had a coordinate plane right here, let me get a different page here. Get a coordinate plane up here. Oh, there's what I want. Yeah, man. There we go. How your Chromebook's been working lately, kids?
Terrible.
Honestly,
everything-
really slow.
Is it? I mean, I think it's like the slowest it's ever been lately. How do you guys feel about that?
Yeah,
Agree or
like,
disagree?
There was like one day I was trying to type on paper and I literally couldn't.
Yeah.
Because my computer was just not working.
Yeah, it's terribly slow right
It
now.
was.
Okay, kids, help me out on the points right there. There's what I want. X, Y axis. Let's go large. Okay, what were the points again? What was the first point that we started with for that vector?
6, -3.
Okay, so how do I get to 6, -3, kids?
1, 2, 3, 4, 5, 6.
And down how much?
1, 2, 3.
I'm going to start at 6, -3.
Yep.
And where are we headed to?
2, 0.
So right 2. You guys agree with that?
Yep.
Okay. And I should write down 2, 0. This is kind of where we're headed, right, for a vector. Would you agree with that, kids?
Yep.
So the thing that I understand here, this point's 2, 0, right?
Yep.
Okay. Is that vector in standard position or not?
Yeah.
Well, is it starting at the origin this time?
Well, no. No, it's not.
Okay, so when we start talking about vectors,
like this right here. What's the question say for example 1 right there? What does it want us to do or find? Say that again, Kate.
What happens to the x's and y's?
What happens to the x's and the y's, right? Okay. So this is an interesting one, the way they set this up. I want to make sure I know what form we want here first.
Okay, this vector right here, if you can imagine me putting this in standard form right here like this.
Oh, he's moving it.
Yep.
If I put it in standard form like this, where's this end up at?
Negative 4, 3. Oh, that's all it's ones.
Right?
Okay. Makes sense.
Makes sense, yeah?
Yep.
Now, it ends up there, right? I have a question here, kids. We ended at 2 comma 0, didn't we?
Yep.
We started at what?
4 or 6.
Quick question. What's the end to, I should say, what's the end x value 2 minus the beginning x value 6?
Negative
What's 0 minus negative 3 for my changes in y's?
3.
So it says what happens to the x's and the y's, you really do what?
Subtraction.
Okay, we take our end point minus our what? Start point, and make this a vector in standard form. Okay, so right here, whoops, I didn't want to do that. It's right down here. Oh my gosh. Where are we end up at? Okay, what happened to the x's and y's? We basically took the end point minus the what?
Starting point.
So we take that end point in terms of x comma y and subtract our start point in terms of x comma y, right? Okay? And that's how they talk about the vectors. They talk about what's the horizontal distance or what's the horizontal change of the vector. Okay? Well, guys, this negative 4 means the vector goes 4 to the left and then up how much? 3. That's all it really talks about. So if I had an example like this, kids, it says find the vector from 7.5 comma 4.3 to what? Okay, what's my end point?
Negative 3.8.
So we would do the end point, negative 3.8 comma
Minus 7.5. Oh. Negative, yeah.
negative 4.1, right?
Yep.
Now what point am I subtracting out, friends?
7.5, 4.3.
Okay, you help me with my North of Highway 3 math skills here, but friends, what's negative 3.8 minus the 7.5?
Negative 11.4.
Ooh, so is this vector moving to the left or to the right horizontally? To the left, because this component, this horizontal component, is what type of a value? Negative, okay. Is this vector then, we went from negative 4.1 minus 4.3, where's that end up at? This is my vertical component. So this is like, we started at a point, we moved left 11.3 units, and we're moving what direction here? Down to 8.4. Where do we end up at? Well, there you go. Okay. Guys, when you have two component vectors, or when you have two vectors in rectangular form, I should say, and you want to know the vector of it, in other words, what's the horizontal change and what's the vertical change here? You're taking the end vector minus the what? Okay. All right, here's a good one. Here's an example. So where do we end up if we're at the point A? Where is point A, kids?
6, 9.
Okay, and then we apply the vector. Oh boy.
17, negative 10.
Okay, so this is kind of like saying, hey, you're going to start with point 6 comma 9. Does that make sense to you? Okay, and when I say apply the vector, they're basically saying I need to take this vector and move. Got to move right 17. And what?
Down 10.
Basically, I'm taking point I started with, adding my change, which is my vector, to get to an end point, which is what?
23 negative 1.
Okay, so where's my start point this time, kids?
6 minus
6.
Okay, and then we're going to add in our vector. And our vector, kids, is telling you how to change, so we're adding like 17 comma negative 10. Kids, help me with the sum of the x's. 6 plus 17, where's that park at for an x value?
23.
Okay. 9 plus negative 10, where's that park at for the y value?
Negative 1.
Okay, so quick question. If I give you a starting point and say, hey, apply this vector to it, can you tell me where we end now?
Yeah.
Okay. Previous one says you start here, you go here. That's telling you what the vector movement was. The horizontal and vertical component change. Okay? Here, I give you the vector and say, where do you end? Do you understand the two, or the difference between the two?
Yeah.
Yep.
Okay. Questions first page, kiddos.
Nope.
Doing pretty good about this so far?
Yep.
Okay, let's move to page 2. Let's see what the heck else is here. All right. So kids, we kind of talked about this a little bit in the last section. It says the magnitude or the distance of the vector, length of the vector, is the absolute value of v, and we use what formula here, kids? Distance formula. The distance formula is just a fancy Pythagorean theorem. How much did the x's change? How much did the y's change? Okay? You're taking a horizontal and a vertical component, and you're saying, I'm going to use Pythagorean theorem because a horizontal and a vertical line form what kind of an angle all the time? 90-degree angle, you bet. Okay? So it says, or use the formula R if you know the vector. So an example right here would be the following. You don't need to write too much on this. Help me out with this. It says, find the magnitude of the vector from where to where, kids?
6 negative 3 to 2.
Well, guys, wasn't this the vector we were looking for from starting at this point to going to here originally?
Yep.
That was this vector right here. I'm going to put it back here, okay? Oops. I'm going to put it back. Okay? If I want to know the magnitude of this vector, guys, what was the change in distance over here?
4.
Wasn't it that right there?
Yep.
What was the change in this vertical component?
3.
Aren't I really going to go 4 squared plus 3 squared again?
Yep.
Yeah.
4 squared.
16.
Think that. 3 squared. I'm thinking that too. What have I banked so far?
25.
25. It's the only way I can make a shot. Is to bank them in. Okay? Square root of 25?
5.
How long is this vector right here? Or in other words, fancier terms, what's the magnitude of this vector? How many units? 5 units. It's just Pythagorean theorem pretty much, isn't it, friends? So right here, they talk about that. They say, well, the 6 minus 2 part was, this was my change in x's. I'm just going to put down here, this was my change in x's squared. Whoops. This was my change in x's squared. Plus, what do you think this is, guys? Wasn't that the change in the y values? Okay, from negative 3 to 0. Okay, well, you get the square root of 25, which means the magnitude must be what? 5. And by the way, then, kids, if the magnitude is 5, then what's that mean about the radius if we were starting to think about polar form again? The radius is the same as the what? And if I found the magnitude to be 5 already, then that means the radius must also be what?
Oh, 5.
5. Okay? Let's talk about this next vector. It says, what's the magnitude of this vector? 5 comma 12. Okay, this would be like saying you're starting at 0, 0, 1, 5, 12. So what's the change in x's, friends?
5.
5. So we're going to do the square root of
5 squared.
what's the change in y's if we're talking about one single vector that we would assume standard position?
12 squared.
12 squared. Okay, I'm not a rocket scientist, but I think this becomes the square root of 169, my friends.
Yep. And then equals 13.
And we're fortunate because the square root of 169 is perfect. 13 units long, okay? Kids, and this is one thing I noticed back in the last section. Some of you, when you're putting your stuff in a calculator, you're like putting negative 2.2 in and squaring it, and your calculator's taking out a negative number. Should your calculator ever take out a negative number when you square something?
Nope.
If you're making that mistake, don't put that negative distance in. Just put it in as a lot right off the bat.
Positive.
Okay, so if you're looking for a distance, just deal in positives. Because you know you're going to square it to get back to a positive anyway, right? True dat?
Yep.
Gnarly. Moving on. It is vitally, vitally. Okay, this is like a lifeline right here. Okay, if we don't do this, we could be in trouble. That's what kind of important?
Vitally.
That you know if you are looking at a point or a what? Vector. That is how you know how to deal with them. Right? Unit vectors, my friend, are listed in terms of I and the second best letter in the alphabet, J. And that simply means that they are like X and Y directions. Okay? I is typically going to be a movement in the horizontal component. Okay? J is going to represent some kind of a vertical component. Okay? So kids, we talk about the vector. 5, negative 6 is the same as 5i minus what?
6.
If I was drawing this vector from 0, 0 to 5 comma negative 6, we could write this as 5i, like going right 5, right? And then minus 6j, or down 6. So as an example, I have a vector A that's written in coordinate form 3 comma 6. And vector B is written as what?
Negative 3, 9.
C is,
6, negative 1.
and what's D, friends?
0, negative 3.
Ooh, this is going to be fun. Okay, if we wanted to add vectors, as an example, we're going to add vector A to vector what?
B.
And we found out in the last section, I can take stuff. Isn't this in rectangular form right here? Or X comma Y form?
Yep.
If I'm in rectangular form, can I just add the X's and Y's?
Yep.
You bet. So we learned that. So if I'm taking A plus B, that'd be 3, 6 plus what?
Negative 3, 9.
Which would equal what?
0, 15.
0 comma 15. You guys tell me what C plus D would equal.
C plus D. Oh, let's see.
6, negative 4.
Yep. 6, negative 4.
I'll reach 6 negative 4 when I add that.
Yep.
Okay. Well, the way I could write this then is 6i minus what?
Negative, or minus 4.
Okay. See the connection there? All right, help me out, friends. Next one, subtraction. They talk about C minus D. Pretty simple. 6 minus 0 is 6. Negative 1 minus negative 3 is 2. So what would D minus A get you?
B minus A. Negative 3.
Negative 3, comma.
9.
All agree, negative 3. So 0 minus the 3 right here would be negative 3, friends.
Yep.
And then negative 3 minus 6 more would be.
Negative 9.
So if I understand, you said negative 3, negative 9, kiddos?
Yep.
What if I wanted to put it in this new vector form involving i's and j's?
Negative 3i, comma 9j.
So negative 3i minus
9j.
9j. Okay. Now this next one, pretty simple. If you want to take 3 times vector A, this would be 3 times 3 comma 6. Distribute. 3 times 3 is what?
9.
9. 18.
18. So this question becomes, what would 6b equal, kids?
Negative 18, 54.
Negative 1854. Multiply these two values by 6, right?
Mm-hmm.
Okay, that's pretty simple, isn't it?
Mm-hmm.
And you said 54, friends? What was it?
Yep.
6 times? Yep, 6 times 9. Okay, here's a tricky one. Let's see if you can do this. Guys, what would 3a minus 2c equal then? This is a trickier one. First of all, what would 3a equal? Let's write it this way.
918.
Okay, 3a. We already know 3a is 918 here, don't we?
Yep.
Mm-hmm.
So this becomes 9 comma 18.
Minus 12, negative 1. Negative 2.
2c would be 2 times this point, wouldn't it, right here?
Yep, 6, negative 2.
So it would
Do
be.
you keep the negative?
Yep, leave your minus sign right there.
Okay.
Okay. And let's do 2 times c here. So this 6 negative 1 would turn to what again, kids?
12, negative 2.
Minus them.
All right. So talk to me, kids. We're going to subtract. How about the 9 minus 12 then? Negative 3. And then what about 18 minus negative 2?
20.
Great. Guys, I don't know. This is pretty much just simply adding, subtracting, multiplying, isn't it?
Yeah.
Just Just got to make sure you keep your horizontals with your horizontals and your verticals with your verticals, right? Okay. I always say it's better to be vertical than horizontal anyway.
Division.
Your horizontal means you're what? Nope.
Laying down.
You're probably dead.
You're sleeping.
I would take
I like
horizontal, laying down, 9
Sleeping is one of my 2 favorite hobbies.
I love sleeping.
What's the other hobby?
Eating.
Math. Where does the pepperoni stick?
I had 2 today. I got an extra pepperoni in my step.
Pep in a step.
You like that?
That's
You like that?
Yeah.
All right, let's go page 3, friends. I'm sorry, I'm so corny. I get it.
It's fun.
You like that?
Yeah.
All right, my friends, recall it. You have to know if ordered pairs shown are vectors or what? Where are my science people? Gator, you're going to have to help me with this today. Did you see Aubrey? I looked at Aubrey and she just said, no. All right. Okay. So let's talk about this. This is really where things are going to start to involve real life. And actually, a lot of what vectors are really a scientific representation of things that go on in real life. Okay? Suppose a force of 6 newtons. Guys, what's a newton?
It's a Newton.
What is a newton?
I don't know, it was a person. It's called I meddled in that.
Object.
It's like a measure of force.
Yeah.
Metric force,
Well,
really?
it says right here, right? It says force of what? Okay. While we're reading through this, somebody Google up what a newton is and then read that to the class. It says, suppose a force of 6 newtons at an angle of what? 70 degrees and a force of,
And the SI unit of force.
are acting on the what? Okay, what's the net force on the object? Let me just show you what the heck is even kind of going on here. It says since there's 2 vectors working here, we will add them together and find their what? Didn't we do that in the last section? Okay.
Okay.
It says bust out some graph paper or protractor. Don't do that. I'm going to do that up on the board here, okay? Now, let's talk about this right here. Will you guys at least remember my forces and my angles for me at least? Can you do that for me? Can you do that for me? I want to make a sketch here as best I
You
can.
try.
Okay, anybody look up Newton yet?
Yeah.
What do you got?
It's basically a unit of force. It's like the unit of force that you need to move an object to cover 1 kilogram per meter per second.
So basically, it's like
How hard you gotta push
Yes.
something to get it
Okay.
to move that fast.
Yep. Okay. So let me get a protractor out here. I think I can do this. Watch this. This will be fun. I want measurement. So I need a ruler. I need a ruler. And I need a protractor.
Yeah.
Didn't even notice. I was looking for the sticker.
So was I. That's what I did. I was looking like a literal white sticker.
There was no. I was, and I was like, wait, what? Why did Josie do that?
Okay.
She didn't mean to.
Guys, here's the deal. Let's talk about this real quick. Okay. What was the first force that we had? 60?
6 newtons.
6 newtons, comma.
70 degrees.
Okay. And then we assume that 70 degrees is made with a horizontal line, right?
Yep.
The x-axis, the positive x-axis, right? What was the other force?
It was 10 newtons at 110 degrees.
Okay. Can you guys see these okay? These multimedia tools up there okay? All right.
Yeah.
Here's the deal. We have an object. I don't know what my object is, but I'm going to say my object is right here. Okay?
That's a small.
We know that there is something pulling on this at 6 newtons at an angle of how many degrees?
7.
Okay, let's do this.
Wait, there's the other should be H.
Here's what I'm going to choose. Come on.
Yeah, there should be H.
Here's what I'm going to choose to do. We're going to form how many degrees of an angle here?
70.
Get it?
Okay. That's pretty close to where that object is center, right?
Yeah.
I'm going to form a 60-degree angle here. You with me?
Why is
Tell me when I get to 60. Or is it 70?
70?
70, I'm sorry. Tell me when I get to 70 with this.
I can't see.
There you go. Back. Yeah.
Oh.
That's 71.
Yes.
Okay, we're going to take this ruler. We're going to rotate it so that it hits 70 degrees with this.
Okay. You're gonna need to keep
You're
going.
gonna
That's
need
too
more
much.
angle there.
Yeah, you're more angle.
Tell me when I'm right on the line, okay?
You're on it.
Fix it. Oh no. No, keep going.
I think that looks about right.
Yeah,
I think
yeah.
that's about right.
Back a little bit. Yeah.
Ooh, yeah, there you
Now
How
go.
long
line
do
it-
I want to measure there then?
I would. Yeah, I would want to line it up. There we go.
Is that pretty close right there to the
Yeah.
end
Yeah,
start
that,
there?
that's like dead on.
What's
So we
the
want to
mass?
measure, I think I'm going to go just a little more.
I think we got to know the mass of the object. Does it give us a mass?
Just our class.
No,
She worked
it
her
does
way
not.
back.
What the heck?
So, the first
Okay, a
one-
lot of times when we talk about forces, they're saying you're pulling on this at 6 newtons at how many degrees?
70.
70.
Okay. Do you guys agree that I'm just going to use 6? The number of inches is going to represent a newton here. Is that okay?
Yep.
Yeah.
Isn't 6 inches right about here?
Yep.
Yep.
Okay, I'm going to draw a point right here. So there's one vector that's headed that way, pulling this object this way. You guys agree with that?
Yep.
Okay, now we have another one at how many degrees?
10 newtons and 110 degrees.
Okay, so I'm going to change my angle on this to 110 degrees. Okay, let's see if I can do this.
Uh, 111. 110. Oh,
Ah.
111.
Shog ditty, the cat in the kitty. That's pretty good there, isn't it?
Yep.
Okay, so we're going to take our ruler now, and we're going to move this around to rotate to 110 degrees. Come on, what the snarf? What the snarf? You make me want to barf. J-U-N-K Ford.
What is going on? You could rotate it to 70.
I know, I could rotate it before.
Can I run to the bathroom?
Yeah.
Why is it going by increments of 45?
I don't know, and I don't want it to.
Okay.
Because
2
we
seconds.
just got it to 70, and that's not an increment of 45. What the heck?
Very, very close to springtime.
Close it.
Can't be something.
I don't know what's going on here all of a sudden. I know what I'll do. I'll get smart. What do I need, 10?
Yep.
I think you outsmarted me. I think you're wrong. Gonna end right here.
Yep, seems about right.
Okay, so let me draw that vector. Okay. My friends, the question becomes, where's the resultant for this?
Well, you tack one onto the end of the
I
other.
could tack one onto the end of the other and know where that's at, right? So we're
Yeah.
gonna kind of try and measure this out and see what happens. So I'm gonna take this second one right here, okay? And I'm gonna try and measure out where the resultant ends up at. So, oh, shaw, it.
What are you doing?
Dab nabbit. Not a problem.
What are you
You gotta be smarter than the average bear. Hey, boo boo.
What's happening?
You think that's a pretty good end right there?
Yeah.
Awesome. So this is a resultant vector right up here. This is the resultant vector going to go from here to here. Okay, I'm going to measure this as best I can. The resultant vector is going to end up here. Okay, now let me measure and tell you what I get, kind of. You guys agree this is where the resultant would end up at?
Yep.
Whoa, that's pretty cool, isn't it?
Yeah.
Let's measure the angle and see how close we are, okay? Oh no, I didn't want to do that. Looks like our angle ends up at about, come on,
93.
that's about as best I can get. 93 or 94 degrees? Is the answer on that paper?
No.
Did that give you the answer?
Nope, didn't give us
Okay.
an answer.
I think I can get close to measuring this. Let's write this down. You guys write it down. What do we get for a resultant vector? How many degrees, first of all? 94 degrees is where those two forces is going to...
Unless it's on the back.
Maybe it's on back. We'll see. Let me.
95.
So we're pretty darn close with the drawing, aren't we?
Yep.
Okay. Let me measure the length here and see how close we are on length. So this is about, kids, I've got about, I don't know, there's about 12 to here.
Oh my gosh.
I'm going to do my best. 11, 10, 2.5. I got about 14.5 measured there. Not perfectly, but I got about 14.5. So I'm going to write down when we measure this. How many degrees did we get totally there?
94 degrees.
And I got about 14.5. It's like 14.5 newtons acting at.
94 degrees.
Yeah. So let's talk about this. Now we've kind of done this already in the last section. That's kind of a guess right there. 14.5. I don't know why I put degrees Newton up there. 14.5 newtons, comma 94 degrees is what we've got about drawing this out. Now, when we think about adding and subtracting vectors like this, a resultant comes from the sum of these. But guys, what form are these in again? Polar form. And I'm not very good at adding stuff on polar form unless we convert to what?
Rectangular.
Okay, so I think that's where we're headed with this stuff. So if I go back here, this is how things are going to work for us. It says to recall that when we add stuff in polar form, and we already did the drawing, okay, we can turn these into rectangular coordinates, can't we? By doing 6 cosine 70 and 6 sine 70 to get the xy for the first vector. Same thing for this vector. Does this stuff make sense right here? When I add the rectangular sums, then this is what I end up with. Negative 1.37 comma what?
15.04.
Okay, so let's see what this looks like then on the next page. On the next page here, oops, you know what that page is on this page. So since we're given magnitude and amplitude at the beginning, we must use a magnitude and an amplitude for the answer to convert it back. So make sure our answer is in the right quadrant, okay? Well, let's talk about this quickly, kids. That angle that we measured was about 94 degrees, wasn't it? Yep. You got to be careful on this, okay? When we do the radius right here, that negative 1.37, 15.04, we're really doing negative 1.37 squared plus 15.04 squared, 15.10. I measured about 14.5, but I was off a little bit, wasn't I? Because I couldn't turn my ruler there in the end. So were we close on that?
Yeah.
Okay. This is the thing I worry about right here. When I do the tangent inverse, we did 15.04 over what? To get what?
84.8.
But guys, that angle that we measured when we actually drew it was about how many degrees?
94.
Not bad.
Are we
Shouldn't
on or
the
off there?
1.37 be negative?
Say that again.
Shouldn't the 1.37?
I totally agree. There's a mistake up here. Run this for me in your calculator. See what happens. Do 15.04 divide negative 1.37. What's that kick out at?
Negative
Ew. Well, guys, the deal is this. If I put a positive in here, you got 84.8, but you're what quadrant, friends?
Quadrant 2.
Yeah, think about this, kids. There's more force pulling. I'll go back to my drawing, okay? When I had this vector right down here at 110 degrees, is there more force pulling in the first quadrant or in the second quadrant?
Second quadrant.
Which means the resultant should end up where?
In the second
In the second quadrant. And if you get stuff that says like negative 84.8 or 84.8 degrees,
That's,
that's not good, is it?
no,
We've got to make sure we're in what quadrant to end with.
second.
Okay, so if we think of this and say, well, 84.8 degrees doesn't make any sense, we got to think about being in the second quadrant as a resultant, because wasn't our resultant over here when we be in the second quadrant or 94 degrees around when we drew that?
Yep.
Well, the way you find it is to take that first quadrant angle and subtract it from what value? This 95.2 that they give here, since you're in quadrant 2,
That's not, huh? Wait, that is in quadrant two though.
yeah, you would have to take 180 minus what?
84.
Or in our case, if we would have put the negative sign up here, kids, we would have had to add how much to this to get to that 95.2 degree angle? Add 180, okay? So the resultant on this really is 15.10 newtons being pulled at what angle?
95.2.
Okay.
I'm caught up in grade books.
You guys good with that?
Yep.
Okay, so let's talk some more.
That's it.
Is that all of it right there?
Yeah.
Awesome. What questions have you got?
I don't have any.
Okay, I'm going to shut this down.